1.60, determine whether this function is even, odd, or neither. I'm going to show you how to do this, and then I'm going to show you kind of a shortcut, and then I'm going to talk about why it's not a great shortcut to use. Note is that I do things very, very, very slightly differently from your book. When I'm checking whether something is even, odd, or neither, what I do is I figure out f of negative x first. Because my test for even, odd, and neither is slightly different than your books. This is identical to your books. Your book here has the negative on this side of the equation. Essentially, it takes this equation and multiplies both sides by -1. I think it's easier to have the negative over on this side, although it's kind of nitpicky, and I'll explain why. I'll tell you right now why. Because I like having f of negative x in both of these things here. Because then with my first step, I figure out f of negative x, and then I use that in both of the tests. So f of negative x, well, here's the blueprint for f of x. I can come up with f of negative x by just replacing all of these x's with negative x's. So I would have negative x to the third power plus 2 times negative x. And if you're good algebraically, you can get rid of these parentheses. Negative x times negative x times negative x, which is what negative x cubed is the negative of x cubed. Most people just kind of memorize why that works. Negative times a negative is a negative. Sure, I guess that works, although you don't know whether x itself is negative or positive, so the logic's a little fishy, but it works out fine. I prefer to think about this as -1 times x, and I take this third power here, and I distribute it, in a sense, down to the -1 and down to the x. And so -1, the one's implied here, cubed is -1, and x cubed is x cubed. Anyways, then I could write -2x here. F of negative x is this thing right here. Let's test to see if it's even. To test if it's even, you ask yourself the question, this thing right here, is that equal to this thing right here? F of negative x, which is this guy, is not the same as this guy. Right? In this case, I'm adding 2x. In this case, I'm subtracting 2x, for example. In this case, it's positive x cubed. In this case, it's the negative of x cubed. F of negative x does not equal f of x, so f is not even. What about odd? Well, for odd, I'm going to again use f of negative x because I do things slightly differently than your book. And then I'm going to compare that to the negative of f of x. You might not even have to write this out, but I'll write it out because this is still kind of new to people. The negative of f of x would be negative, and then I'm going to copy this thing that I know f of x is, x cubed plus 2x. And the question is green the same as blue? If green is the same as blue, then this function is odd. If green is different than blue, this function is not odd. You might have trouble seeing that these two things are the same, but if you got rid of these parentheses, if you took the negative and distributed it through the parentheses, you get negative x cubed minus 2x, which is the exact same. Green and blue are the same. F of negative x equals the negative of f of x, so f is odd. I don't know if the exclamation point is necessary, but this function here, it is odd, it is not even, so therefore not neither either. Yeah. Why is this odd? It ended up being odd because each of the terms, this thing separated by plus and minus signs, are raised up to an odd exponent. This is really 2x to the 1 power. Yeah, you can do that. Everyone wants to shortcut these for some reason. You want to come up with rules that always work. Be careful. If this were x cubed plus 2x plus 1, for example, that wouldn't work. If this were x cubed plus 2x all divided by x to the 5th power. Oh yeah, that would work. Those are all odd exponents. Nope, it wouldn't. So be really careful trying to come up with these broad generalizations. I think it's better just to go through the tests. I admire your creativity in trying to come up with these rules that will always work, but I think it's easier just to do it this way. I'll end this example here.